All right, seniors, I'm excited for you. I remember how that felt back when I was in school. It's hard to concentrate, but we're almost to the end. We're almost to the end. In fact, I've put up. Let me put up what we're doing right here, and I'll show you. I've made a decision looking at this. We're going to finish easy. Juniors, I'll have something for you the next 2 weeks. Don't worry, it won't be in our textbook. So here we go. If we look at our grade screen, we have 2 assignments left: the fundamental theorem of algebra and the rational functions and asymptotes. And I've decided we're not going to do rational functions and asymptotes. We're only going to do the fundamental theorem. I'm going to excuse lesson 8.06 from everyone. Don't have to do that one. I'll make sure there's no questions from it on the final. But this is going to be our last lesson, the fundamental theorem of algebra. And you've already done the fundamental theorem of algebra. We just haven't put it in a lesson form. So let's look at it real quick, and then I'll tell you how this week is going to pan out for all you senior folks. All right, the fundamental theorem of algebra lesson right here. All right. In our initial discussions of polynomials, we saw that the nth degree polynomial has n real zeros. If it's a 3rd degree polynomial, it has up to 3 real zeros. If it's a 7th degree polynomial, it has up to 7 real zeros. But when we expand our set of zeros to the complex numbers, which is the imaginary numbers, 2 plus 3i, etc., we can say that every nth degree polynomial has exactly n zeros. If it's a 6th degree polynomial, it does have 6 zeros. Just some of them may be imaginary. Maybe. Could be real. But if you include the imaginary, it's guaranteed to have 6. So this is the fundamental theorem of algebra. We know from the fundamental theorem of algebra, which states if x of x is a polynomial of degree n, where n is greater than 0, it has at least 1 0 in the complex number system. All right, that complex numbers, that includes imaginary. All right, guys. So then it goes into a lot of mathy stuff that says, expanding this, we get the linear factorization theorem that says if f of x is a polynomial of degree n, where n is the largest term, and then it's smaller and smaller. So if n is 4, it's the x to the 4th with whatever coefficient of the 4th is, plus x to the 3rd, plus x squared, plus x, plus the constant. And it'll have exactly n factors. So if it's a 4th degree, there'll be 4 factors, where these are complex numbers, and this is our coefficient. So, for example, if you have a 1st degree polynomial, x minus 5, there is 1 0. If you have a 2nd degree, x squared minus 7x plus 12, there are 2 zeros. If it's a 3rd degree, there are 3 zeros. If it's a 4th degree, there are 4 zeros. And notice with x to the 4th minus 16, the zeros are 2, negative 2, 2i, and negative 2i. So 2 of those are imaginary. That's complex numbers. That's 0 plus 2i and 0 minus 2i. There are 4 because it is a 4th degree. But it doesn't mean they're all real zeros. Some of them are imaginary zeros. So it gives you a test your skills to see, can you find the zeros? You're looking for 4 zeros. You're looking for 5 zeros. And then just checking your answers. So you'd have to factor those, or if you can graph those, but graphing those is only going to show you the real zeros. It's not going to show you the imaginary zeros. So find the zeros of this. The answers are right here. When you click on that, it'll show you your answers. So if you want to test your skills. And then graphing polynomials, we'll use all the techniques to analyze and graph a polynomial function. You'll practice using the degree, the x-intercepts, y-intercepts, approximate coordinates of the relative maximum and minimums to figure out the shape and features. So conjugate pairs, that's just talking about the zeros that are imaginary. Right? Each time that complex zeros occur, they're in pairs. And we've talked about this. They're called conjugate pairs. So if a plus bi is a 0, A plus bi. Then a minus bi is also a 0. That's its conjugate pair. That's its conjugate buddy, right? When you have complex zeros, they got a buddy. It's the buddy system with imaginary zeros. So if it's 3 plus 2i, then its buddy is 3 minus 2i. It's always going to have a buddy if you have an imaginary zero, a complex zero. So that way, if you find one, that automatically gives you the other. But remember, there's always 2 if there's an imaginary zero, or 4, or 6. They're always in pairs. All right. So the rule concerning factors of a polynomial states every polynomial of degree n is greater than 0 with real coefficients can be written as a product of the linear and quadratic factors, where the quadratic factors have no real zeros. Right? Real coefficients, quadratic factors. And then here, if you want to get into it, this is just the summary. Here is the actual lesson that you can read, which gives you more examples and goes deeper into the discussion. But we've already hit the highlights of it. See, it's got some graphs of some of these over here. This one has no real zeros. So that's only imaginary zeros. X minus 2i, x plus 2i. So but if you want to go through that, that talks about the complex conjugate zeros again, which we have up there in the summary, where it says a plus bi and a minus bi are both zeros. So anyway, more examples down there. Just give lots more examples that you can go through if you need a better understanding. Oh, that's a good point here. The polynomial function of odd degree. Every odd degree has at least one real zero, because remember, when it's odd, it will cross the x-axis. Right? Odd, even, it could bounce off, but if it's higher, it won't even touch it. But an odd one always crosses. So there's going to be at least one real zero with every odd degree. Could be more. All right. Let's look at the lesson for this week. Let's look at the assignment for this week. It is multiple choice. Polynomial function of minimum degree with real coefficients that have these zeros. 1, 2, 3 zeros listed. But notice one of those zeros is imaginary. So are you writing a third degree? No. Look, all the answers are fourth degree. Why are they all fourth degree? Because there's another imaginary zero. So you have to write those factors. Like if one of the zeros is 3, that means the factor is x minus 3. So x minus 3 is one of your factors. X plus 13 is one of your factors. X minus 5 plus 4i. X minus 5 minus 4i. And then you multiply all those together and you will get one of these 4. And remember, if you have an I squared, that becomes negative 1. Because notice there's no i's left here. The i's will cancel out because they'll become I squareds. All right, state how many imaginary and real zeros this function has. All right. How many is, you can graph that to figure out how many real ones. You can look at the equation to tell how many zeros. Write the linear factoration of this. So write the factors. Which one of these is correct? Which of these would multiply back together to be that? And then here, don't make this hard. Using the given zero, they're giving you 1 0, find one other one. You don't have to find all the zeros. It's x to the 4th. Find one other one. And notice the one they give you is an imaginary 0. 2 minus 3i. That's a big hint on what another 0 is. Shouldn't take a whole lot of work. And explain how you know that. That should be real quick also. All right, so don't make this real hard. It gives you one imaginary 0. We know something about imaginary zeros. Hint, conjugate buddy. So, all right, only 4 questions. That's it. That's it. And like I said, I'm going to excuse lesson 8.06, rational functions and asymptotes. It's the end of the year. If you want to do that, that's fine. I'll count it if it raises your grade. If it didn't raise your grade, I won't even count it. If you don't do it, I won't count it. I'll only count it if you do it and it raises your grade. Semester final. Let's talk about that. since almost everyone in here is a senior. For you seniors, juniors, this doesn't apply to you. For you seniors, all work, if you want to be exempt from the final, if you haven't missed more than 4 days, if you haven't missed more than 4 days in advisory, have your work in by 7 a.m. Thursday morning this week. Because Thursday, I'm going to send out the exemptions. I've got to come in Thursday. I got to check your attendance to make sure you haven't missed more than 4 times. Got to check your advisory attendance. Have to make sure your grade is at least 75%. If it's not 75%, you have to take the final. And no missing assignments, which includes practice assignments. So if you didn't do any of the practice assignments on those matrices or didn't do a practice test, you've got till Thursday morning at 7 a.m. to have those turned in if you want to be exempt. But again, if you've had too many absences, doesn't matter. Can't be exempt. So that's Thursday when exemptions go out. Friday morning, I will release the final. The final will be available Friday morning. It is due Monday night at midnight. Again, if you're not a senior, your final will not be this weekend. But I will release the final Friday. You have until Monday at midnight to do the final because I have to turn grades in for seniors on Tuesday. On Tuesday, your grade is finalized, and I submit your grade and said, this is it. So, for missing work as well, if you want to be exempt, it's Thursday morning at 7 o'clock. But if you can't be exempt but are still missing some assignments, and at this point, I'll take anything that you're missing. Nobody's missing anything beyond 6.03, but there are some people missing 6.03. You can still turn that stuff in until Monday for your grade. You can't be an exempt if you turn in Monday. You have to turn in before Thursday morning for a possibility to be exempt. But if you don't make the Thursday deadline, don't give up. I'll still accept that to affect your grade. If you want to turn in something that's a 0 and want to raise your grade by getting it turned in, you can still do that until Monday. But like I said, Tuesday, I have to turn all your grades in. It's too late on Tuesday. So, all right, we understand those deadlines. Thursday morning, 7 a.m. to be exempt. Monday, for it to help your grade. All right. Friday, you will have the final released on Buzz. Monday, it's due if you're not exempt. And remember, if you are exempt but take the final anyway, I will not lower your grade if you do poorly, but I will raise your grade if you do well. All right. So the final can only help you if you are exempt. So that's an option if you're exempt. Okay. Any questions on any of that? Pretty clear? Fabulous. Well, seniors, if I don't see you again, this is an A week. So if you need to be here grade wise, and there may be some, I haven't looked at the grades this morning, but if you need to be here grade wise, I'll see you Wednesday and Friday, unless you get your grade up. But otherwise, go rock it, seniors.